Adhesive tape was invented in 1925 as a painter's masking tape for auto body shops. That led to transparent tape, designed to seal the cellophane wrap used by the food industry. Then tape was introduced as a household item, and the idea just stuck. These rolls of plastic film, called polypropylene, are on their way to becoming shipping tape. The rolls go on a machine called the unwinder. Workers then position a strip of adhesive splicing tape along the end of each roll. This will enable them to connect one roll after another, creating an uninterrupted feed to the production line. Now watch closely. Once a roll unwinds completely, its end sticks onto the splicing tape at the beginning of the next roll. Once that roll's unwound, its end will stick to the beginning of the next, and so on. An automatic tension adjuster ensures that the machine pulls the film evenly to prevent ripping. The unwinder also applies a solvent to the film surface. This prevents the film from sticking while unrolling. To transform this film into tape, they coat one side with a hot adhesive known as hot melt, made from several ingredients. Synthetic rubber gives it flexibility. A UV protector keeps it from drying and discoloring, while an antioxidant prevents aging. Synthetic resin makes it sticky, while pigmentation oil provides a choice of colors, in this case, tan. They load the hot melt into a preheated holding tank, which maintains it at a piping 200 degrees Celsius to keep it from hardening. The tank pumps the adhesive to a machine called the gluer. They wipe away the excess, then roll the film. And there goes the adhesive. A cooling roller, that black one on the top, immediately hardens it. A computerized sensor ensures there's an even coat of adhesive. If not, it automatically signals the pump to adjust the output. Now, a machine called the rewinder rolls the tape onto spools. Remember the unwinder that spliced the rolls together? Well, the rewinder unsplices them. When a spool fills, a knife separates the tape at the splice point so that winding can begin on the next spool. The tape on just one of these spools would run the length of 85 football fields. The spools feed a row of sharp razor blades called the slitters, which divide the 1.5 meter wide tape into several strips. Shipping tape is 48 millimeters wide, so they get 31 strips per spool. Each strip winds onto a cardboard core, its end sealed with a tab. The length of tape per roll varies according to the customer's specifications. As the machine ejects the finished tape rolls, in comes the next batch of cardboard cores. Then it's off to the packaging department. Nothing's shipped out, however, before a quality control check. They test a sample roll from each spool. In one test, they unroll the tape sticky side up, then release a tiny stainless steel ball down an incline, measuring how far the ball rolls before it sticks and comes to a stop. To pass the test, the ball has to adhere within a certain distance. The stopping distance varies depending on the type of adhesive tape.
All consumer products are packaged, and the making of these packages starts with the burning of an aluminum plate like this one. This animation illustrates the burning process, the transfer of an image onto an aluminum plate. The plate is placed onto a cylinder, and using a laser, the burning begins. The image appears in 6 minutes. This plate will make the printing impressions on packages. The laser which did the burning has to be perfectly calibrated using this test plate. The plate is now ready to make impressions via the offset method. Printing involves ink, and it requires selecting the right one. If the desired color does not exist, it has to be made up from a mix of various other colors. An ink trial is done with a spatula. And using this small manual press, color ink tests are done. The ink is spread onto paper, and the color compared with the one called for by the customer. If the two match, the presses can be started up. This is a 6-color offset process printing press with a 72 by 108 centimeter capacity. The press is fed by a suction and friction process, devouring 8,000 sheets an hour. Now the printing plate is placed onto the press cylinder. This plate will contact inking rollers of the ink reservoir. To prevent it from drying, ink viscosity is maintained with this oscillator. The press starts up and reaches a production rate of 8,000 impressions in 60 minutes. The press comprises individual color printing units. The paper sheet passes from one unit to another, receiving a new color at each step. Here they register the colors, that is, the quality of the superimposition of the different colors. The final step is the folding and gluing of the boxes. This grooved plate makes folding point marks on the carton. And this machine does the cutting, the embossing, and stripping of the sheets at a rate of 6,000 an hour. The cutting die cuts the carton sheets and, together with the grooved plate, makes the folding joints. This sheet is slid behind the cutting die to equalize the cutting of the sheets. This enormous pile of 3,000 sheets is ready to be cut. The embossing press feeder handles between 6,000 and 8,000 sheets an hour. Rollers guide the sheets in the direction of the press. And here, the sheets are embossed by the machine. The precision of the embossing is then verified. Next comes the cutting of the sheets. This goes on at 8,000 an hour. The cutting unit strips and removes the unnecessary pieces, and the carton scraps are sucked up for eventual recycling. The scraps can also be cut away manually by using a hammer. And the carton end pieces are sent off for recycling. All that remains is the assembly of the packages. This high-speed gluing unit can make up 30 to 40,000 per hour. Gluing begins with the folding of the sheets, following the folding marks. The sides of the formed box are then glued together. An average of between 5 to 8 steps are needed to fabricate a packaging box. Every day, this plant produces between 1 and 2 million boxes, requiring almost 4,000 tons of cardboard annually.